Hello, good morning everyone. Today I welcome you for the third day of your international STTP on advanced application AI and ML. I welcome to Sonia ma'am also, today's speaker. Sonia ma'am has 14 years industrial experience with varied areas of technology ranging from web development to security, network, and from image processing to programming language. Currently, she is working as a technical instructor in NPower, Canada, Toronto. She has also worked as an IT instructor and educational facilitator at many industries and institutions also. She worked as a network and system engineer and SQL Server administrator in Intergraphic System Private Limited, New Delhi, India. Now I welcome to Sonia ma'am for today's session. Hand over to you, ma'am.
Thank you. Thank you so much, Devyani. And can you hear me? Am I audible to everyone?
Yeah, you are audible.
Okay, yeah. So a very, very good morning. It's 12:30 a.m. here in Canada, but I'm sure it's a beautiful morning down east in India. And it's really great to see so many participants. I think it's 88 and the count is rising. So it's indeed very encouraging to have such a great audience. And I honestly did not know that it was the faculties to whom I will be giving the presentation to. But yes, it's going to be great. And I'm sure that if there are faculties who I think it's going to be more interactive, I believe, rather than just me lecturing and just talking about it. So whatever, contributions you have, insights you have, do not hesitate and just text me or raise your hands. And it's going to be a great learning experience for myself and for everyone who is in here. So Ms. Devyani just shared the schedule for today with me. Just let me, yeah. So today I think it's myself, and then it will be followed by Mr. Ben Gary, who will be giving you the presentation on application of AI and ML in big data. So I think since yesterday you just had one of the presentations with quantum machine learning, and then there was someone who presented the cybersecurity parameters for AI and ML. So I think today's presentation is going to be a good start for you to carry on with the further STTP and the lectures that you will be having. So anything you want to ask, like before we just jump into the presentation, anyone want to ask anything, talk about anything? I just don't want the day to start with anything very heavy. So anything you want to put forward, I'll be glad to talk about it. Or should I just hit directly to the presentation? Whatever you suggest. Okay, I can see.
Ma'am, we can start with presentation.
Okay, cool. So I will start with the presentation. Okay, so let me share my screen. Can you all see my screen in here?
Yes, ma'am.
Yes, ma'am.
Okay, cool. So that's really awesome that you can all see my screen. So I'm going to touch base on understanding of the machine learning concepts and its applications. So yeah, so the topic was AI and its application, or machine learning and its application. So we're going to touch base on the machine learning concepts, and definitely we are going to talk about the applications of machine learning and AI as well. So AI, understanding of machine learning concepts and its applications. Moving on, let me show the presentation mode. Is it on the presentation mode right now?
Yes, ma'am.
Okay, cool. All right. So what is machine learning? So before we dig into it, what is machine learning? So let's talk a little about machine learning. So machine learning is something that allows the users to look for the patterns in a data set and use that information to make future predictions. So basically, we are looking the pattern, we are looking the behavior, we are kind of studying, we're trying to analyze the different things as we go forward in time with. And then after we have that data with us, we are trying to predict something that is going to happen in future. So that is what, broadly machine learning is all about: having the data, understanding the data, and moving ahead with that data, analyzing that data. So that is what machine learning is. Commonly, it is used in the finance industries, for example, enabling banks to detect suspicious transactions, stock predictions. So definitely, nowadays, a lot of fraud things are happening. You talk about the finance industry, or you talk about any of those financial institutions, maybe the banks or maybe the stock exchanges. So things do happen. So looking at the data, looking at the information, looking at the pattern of information that we have, we try to predict what is going to be the future outcome of it. So that is what machine learning is all about. So we have a different kind of data. I'm just emphasizing it again and again so that it gets imbibed into your heads. So learning on the data, analyzing that data, that is what is something machine learning is all about. We have to train our machine learning model on a set of features within that data. So definitely when I'm talking about data in terms of machine learning, so data has to be confined within that perimeter, within that sphere of thing that we need to analyze. So that is what very important. So the data need not to be very random. So if I'm talking about a bank, if I'm looking at one kind of a problem, the data needs to be something about that information that I need to predict, something about that information that I want to extrapolate. So that is very important, that while you are training your machine, while you're educating your machine or learning model, as you call, the set of features within that data are taken into consideration. A very good example of, I'm sure a lot of you, I can see so many PhDs here on the list as well. So I'm sure that, when you might have studied or gone through what machine learning is all about. So very good example is how you train a child to cross a road, right? So when you are crossing a road with your child or with children, they don't know how to look at the signals. They don't know whether to wait at the red signal or to just taking a decision at the yellow signal and then probably go at the green signal while you are crossing the road. So when the child, he or she is going with you and he or she observes the signal and he observes the pattern, his brain gets trained or her brain gets trained, and accordingly a future prediction happens. So this is where the machine learning algorithm actually came into existence. Going into a little history, how we actually started with this machine learning. So training it with repeated sets of data and then analyzing the pattern, or then kind of conceptualizing the pattern, is something what is called as machine learning. So example, I'm just trying to give one of the examples, like banks detecting fraudulent transactions. So the various features of transactions. So if there is a bank and there is some kind of a transaction that has happened, which appears to be a fraudulent transaction. Any questions? I think somebody's mic is turned on. Okay, all good to go? All right. Okay, so let's moving forward, just like to give an example of banks detecting a fraudulent transaction. So if some kind of a fraudulent transaction has happened in the bank, or there is a kind of a suspicion, there is a kind of a doubt, or there's a kind of a probability that some kind of a fraudulent transaction has taken place. So what really a bank does? The various features of transaction would include vendor information, time and date of transactions, transaction details, etc. So these are the data points that we have which are associated with the transaction. So generally, whenever you are making a transactions from a bank or inside a bank, these are the 3-4 vectors that we have, or 3-4 data sets, or the information data pieces that we have. We have, I'm so sorry. Yeah. So it'll include the vendor information, time and date of the transaction, and of course the transaction details. So now when we have these data points, or when we have this kind of an information available with us, there will be a model. There is a kind of a model that we have created to look into the pattern of these data, to look into the pattern of these information that we have extracted or collected. So a model would look at all the past transactions, which would include both fraudulent and non-fraudulent transactions. Of course, as of now, we don't really know whether this transaction that has taken place is actually a fraudulent transaction or it is a genuine transaction. So the machine does not know. It has to actually predict whether the transaction is a fraudulent or it is a legitimate or a genuine transaction. So with all the kinds of data that we have, it is going to look into the past transactions and analyze the likely values for each feature such that a fraudulent transaction is most likely. So the machine has, from the previous records, the good transactions or the legit transactions or the genuine transactions. It will also have the fraudulent transactions. The machine knows what kind of a transaction has to be put in the category of the good ones or the genuine ones and what is to be put in the category of the fraudulent ones. So the kind of transaction that has taken place today, it is going to then compare that transaction with the previous data set it has, the machine has, or the model has. Thus, when we feed new transaction data into the model, it uses the information learned from the previous transaction to predict whether the current transaction is more likely to be fraudulent or not, and then it will classify it accordingly. So that is what I said. So based on the previous information that we had, based on the previous data that was fed into the system, into the machine, into the model, and looking at the previous data, whether it was, as I said, it had the good ones and the bad ones as well. So the present data, which is fed to your model, which is fed to your machinery, the model is going to compare the data from the previous data and then accordingly make an analysis whether the current transaction that has taken place is a good one, is a legit one, or is a bad one. Okay, now these are like common terms that we've been using and revolving around when you look into this machine learning, neural networks, artificial intelligence, deep learning. All these things, just go round and round, and we do get confused, like whether we are focusing on the machine learning ideas or whether we are focusing on the artificial intelligence or it is something, the deep learning we are talking about. So yes, these terms are connected, and if you really want to dig into the details of it, and if you go into the further research of it, you will definitely be able to be more precise whether you are dealing with AI or whether you are dealing with machine learning or deep learning, or AI is the broader concept and machine learning and deep learning are the subparts or the subsets of the broader umbrella that we have, which is called as artificial intelligence or AI. So artificial intelligence is a broader term that includes both machine learning and deep learning. So you can say that artificial intelligence is like a big umbrella, and inside those artificial intelligence, we have machine learning, we have deep learning. So if you're talking about machine learning, it somehow maps to artificial intelligence as well. If we're talking about deep learning, definitely it maps somewhere around artificial intelligence as well. So yes, they do go around about each other, but then yes, if you want to dig into the more precise details, you shall be able to figure out whether precisely this kind of an algorithm maps most appropriately with either of these three terms or not. So for example, the chatbot. So chatbot, anyone, what is a chatbot? Yeah, but if you can just type in the chat, I mean, yeah, so the chat room, you can just type in here. I just don't want the lecture to be just one-sided, like, because we all are from the fraternity of the faculties, and I hope, since this virtual environment has come up, so, just we don't even know your cameras are off. I don't know how you're reacting to my lecture, how you feel about it. So if you're just going to write in the comments, it's going to be really great, for me as well, and I'm sure it's going to be good for you as well. All right, so proceeding further, chat bot. So whenever you use the word bot, it is actually a robot, a chat bot. The word bot means something which is artificial, something which is not human. So the chat bot is that you have certain applications. You say, okay, chat. You have Myntra as one of the sites. Your order didn't get delivered to your doorstep, or you have Flipkart, or you have Amazon. So you just have a chat room there. So it's not always the real person who is sitting in there and giving you the resolution, at least for the first 4, 5, 6 steps, because that is something that is how should I put it, that is something which is very much standard. It is going to ask you, hey, what is your problem? You're going to say, okay, my order didn't get delivered. All right, so can I know your order number? You say, okay, this was the order number. So do you have the tracking details? So these are the 4, 5, 6 common questions that a chatbot does. So it's not really the real person who is sitting in there, it's a chatbot who does that. So this is actually something, what you call it as an artificial intelligence. So this is an example of how AI is, seeping into our systems, seeping into our business systems and other systems, and how we are making a good use of it. So once you have those 4 or 5 initial entries, like, okay, hi, I'm Sonia. This was my order, and then that's going to be an automated question. Okay, so what was your order number? So even if no person is sitting there, it is something which is automated, something which is already there. So I'm going to type in my order number. Okay, what was the problem? It got delivered. I want to exchange it. I want to return it. These are the standard questions. And once it reaches the point where the machine cannot take it further, that is a point when the entire thing is transferred to some human or to some person who is sitting there at the customer service and taking care of your query or of your question. Please stop me whenever and wherever you want me to stop, and let me know if I'm being too fast or if I'm being too slow as well. Okay. Okay, so on the other hand, like we just talk about the chatbot. On the other hand, see, this is something really strange. Okay, so I was just talking about Myntra, and somehow the Myntra icon popped in onto my screen, right? So this is something we're going to talk about it. So that's interesting, and I'm sure most of you know about it. So on the other hand, the Google Assistant on your phone, which needs to understand what you speak and consequently respond by performing the task that you ask it to perform. And this is based on deep learning. So we talked about artificial intelligence as a chatbot. Now, when I'm talking about the deep learning, so deep learning is another kind of a subdivision or a subset of AI. So Google Assistant that you have on your phone. So that is something that is based on more deep learning models. So when I'm talking about the deep models or deep learning models, which analyze the input at multiple layers and performs the task accordingly. So unlike the artificial intelligence where we have something more pre-configured, the deep learning is, it's more, it requires more analysis. It requires a lot of layers, and working on those layers is going to give you the appropriate solution to the problem that you are trying to figure out. So Google Assistant, for example, is one of the concepts that essentially works on deep learning. Okay, so some machine learning applications, since we are to talk about some of the machine learning applications. So e-commerce websites. So yes, we did talk about Myntra. We did talk about other e-commerce websites. So all e-commerce websites use a recommendation engine to maximize their sales and customer share of the wallet. So that is what is happening. So all those e-commerce websites that we have, especially with this pandemic, so e-commerce did actually take a boom, and did actually take a rise. So we initially thought that this pandemic is going to shut down everything, but I think e-commerce is one of those platforms, or is probably one of those areas which flourished a lot, especially during this pandemic. So be it online shopping, be it online grocery ordering, or anything like that. So e-commerce websites use a recommendation engine. So there's a recommendation engine. So the word recommendation, so it's a kind of a thing, like if I'm searching more of, okay, let's say, for example, I'm searching more for the smartwatches, right? So I'm just Googling, okay, which is the latest smartwatch available in the market? What are the features? So it works on your recommendation. It works on the kind of searches that you are making. And then based on those searches, it's going to provide you with a recommendation. So it can work on the searches that you are making. It can also, take your data while you are talking about it. It's going to take the data, probably when you are on the YouTube or some of those commercial sites. And then based on the kind of searches that you are making, based on the kind of things that you are surfing, it is going to make a recommendation. So this is one of the applications of machine learning. This is how your machine is learning what kind of things you are looking in for when you are talking about e-commerce, or when you are talking about machine learning associated with e-commerce. Then, of course, the manufacturing sector. So when I'm talking about the manufacturing sector, so various manufacturing operations involve the processes that are governed by specific levels of components that require maintaining specific environmental conditions. especially when I'm talking about something like maybe a PCB, manufacturing of a PCB. It requires a temperature control. You need to have a particular temperature control if I am talking about these microchips or maybe the embedded chips that are there into your computer, that are there inside your laptops, or some other functionality which are temperature sensitive. So such environment, such manufacturing requires a kind of an environment and some kind of an environmental conditions, say, for example. So in order to monitor these conditions, companies normally use some kind of the detection systems which warn the engineers if any processes go out of control. So if the temperature is going high, that's definitely going to damage the PCBs that you are making, the chipsets that you are making. So there has to be some kind of a monitoring system that is available, and it is going to monitor it, and then it's going to send an alarm, send an alert to the engineer, so that the future damage is not happening to the manufacturing things or to the components that you are manufacturing. It could range from anywhere. Just chipset is one of the examples. Healthcare, of course. I mean, how can you not think about healthcare when you're talking about machine learning? So machine learning has also worked wonders in healthcare industry, be it identifying the optimal treatment options or providing accurate diagnostic reports. Machine learning has been involved, and it is associated with other components of machine learning as well. So when I'm talking about healthcare, definitely, again, I'm going to cite examples of COVID for sure, because that is something which is on, no matter which part of the geography we are here around the globe. I'm in North America, you are there in India, so we all are hit equally by this pandemic. So healthcare is one of the industries that is definitely taking an advantage of machine learning. So with the statistics that we have, we predict how the second wave is going to be, how a third wave is going to be, how the Delta variant is going to affect us. So this is all machine learning is doing. With the previous data, with the previous inputs that we have, we are able to predict how the picture is going to be in the future. So healthcare definitely is allowing you to predict the future of this COVID, and definitely other parts of the healthcare definitely are also using machine learning algorithms to maybe detect or understand or diagnose the problems that we have. Machine learning and cloud. So there are we talk about machine learning applications. We talk about just a little difference between AI, ML, and DL. How a machine learning does those detect those bank fraudulent transactions. So now let's talk a little about machine learning associated with cloud. So anyone who would like to contribute what cloud is? I mean, I know you all know what cloud is, just that probably giving a little rest to my throat. So if somebody wants to just talk about what cloud is, it's going to be great. No one? Okay, I just want a thumbs up for those who are listening to my presentation. Just a thumbs up, just a virtual thumbs up. So whether you are just in here, okay, STTP in charge is listening to my presentation. Thank you very much. I just got one of the thumbs up in here. Okay, I think it's just one-on-one between me and STTP in charge. Whoever you are, sir, ma'am, thank you very much for all your ears in here. So yeah, so am I just speaking, or is just like everyone mute, off the cameras, doing their chores, making their coffee, tea, sandwiches? It's early in the morning. Okay, so I can see some chat. Okay, yes. Okay, good. Awesome. Thank you very much. Thank you. So those yeses, they really encourage me. Trust me, it's 12:30 a.m. here. It's past 12:30, I think. Yeah, it's almost 1 a.m. here, 12:55. Tomorrow I have work, but I'm all in here, so I want your support. And I'm definitely younger than you all, right? I see all those doctors and all those experienced people. I mean, when I leave this conference today, I want to be, enriched with some more insights on whatever I'm presenting right now, or maybe something else that you would want to contribute. Naina, I think she raised the hand. Naina, you want to say something? Or is it a thumbs up? Naina? Okay, maybe it was a thumbs up. She just raised her hand. Okay, so okay, I cannot see. Cloud computing services is a cloud. Google Colab is a cloud environment. Yes. On-demand resource sharing. Yes. HOD computer, MMIT. Thank you, sir. Thank you, ma'am. I don't know whether you're sir or ma'am, but yes, just trying to be gender neutral. Nice presentation. Thank you. Thank you. All right. So yes, we know what cloud is. A cloud is a cloud, and then it rains something. So what is that cloud raining about? So what we are storing in the cloud is going to rain the same information. So we want all our information. How does the cloud work? How are the clouds formed? Basic science, basic physics, that is where the concept was taken from a grade 4, 5, or 6. So evaporation is taking place. They are forming the clouds, and wherever there is a right temperature that we need, the rain falls down. So here also we have a cloud, but in this cloud we are storing different kind of information, because we cannot store all the water here on our planet, on our computers. So the water is the data. So we cannot store so much of water into the small chip. So what we do is we put it onto that cloud, and whenever we want the cloud to rain on us, we have that facility, or we have that ability, so that the cloud showers the information that we need to access. So we share document routinely via Google Drive without even realizing where the server stores these documents, right? So the storage space is nothing but the cloud. So that's what we talk. So the storage space is nothing but the cloud. So the data or the information, just take it as water, and this water is evaporating into the cloud storage. So the storage space is nothing but the cloud, and this is an external location which involves servers or data centers, which you can access over a network. In technical terms, cloud refers to virtualization of services such as storage, computing power, etc., and delivering these services over a network. So this is a very important line, delivering these services over a network. So it's not only storing the information, it's not only storing your data, but also delivering that data, delivering the services which you are storing on the cloud to different parts of the network. So this is a catchy line, delivering these services over a network. All right, I don't know what happens to this Zoom sometimes. Yes, okay. So another example, similarly, let's say that you are visiting different websites. So we're talking about machine learning and cloud, right? So this was one of the aspects of cloud, where you are storing some information, storing some kind of services on the cloud. Let's see what the future slide has to say for us. Similarly, let's say you are visiting different websites. So the traffic across these websites may not be same all times. So definitely you have different websites. Okay, I'm being a woman. I'm not trying to be a little stereotype, but yes, being a woman, I'm really crazy about online shopping, especially when this pandemic has come and we cannot really go out to the malls or to the shopping centers or shopping stores to find something for ourselves. But yes, I have Myntra, I have Agilo, I have maybe some other websites. So different websites, we are surfing across different websites in parallel. It's not just one time. At the same time, we are surfing across different websites. Now, how will these websites handle such varying traffic? Maybe at night, it is a Friday night, I don't have any work tomorrow. So maybe I'm going to spend more time on Friday night. Maybe it's Monday morning. Definitely I have work, and Monday blues are there. I have so many tasks to perform. I cannot do anything, apart from just doing my office work. So the times, or the number of times I'm hitting one of those e-commerce sites, is going to be less. So the traffic is varying. It's a variable or a variable. It is not something which is constant. Now, how will these websites handle such varying traffics? They cannot simply add more servers to handle their computational needs, which can vary every minute. So sometimes the traffic is too heavy, sometimes the traffic is too low. So we cannot have a fixed kind of a system that is going to work for everything, right? So it depends. Like sometimes we have students who are very smart in the class. We all are teachers, professors, lecturers, faculty members. Sometimes we have a great batch of students. Sometimes we have mediocre students. Sometimes we have students who probably have different kind of learning abilities, and we need to cater to them, right? But then yes, as it says, that teacher is something that can modulate himself or herself accordingly. But then this machine learning is not a teacher. So the computer is not a teacher. So first, let's be proud of what we are. All right, so going back in here again, so how these websites are going to handle this variable traffic, what algorithm it is going to follow. So because we cannot have one fixed thing, so instead they use hosting services. So these provide the necessary infrastructure to meet their processing needs. So different processing needs depending on different kind of traffic, to handle traffic low, traffic medium, traffic mediocre, or traffic to be very high or dense. So we are using different kind of hosting services to meet this kind of processing needs, different kind of various kinds of processing. Okay, now we had two examples about the storage, about the handling of the various kind of traffic densities in terms of surfing on different sites onto the different sites. So the two examples above are those of cloud solutions where the necessary infrastructure, such as storage. The first example was about storage or memory or computation. The second example wherein we don't know what kind of a traffic density we are going to have, so it requires computation power, are provided over a network, thus allowing you to perform operations that might be difficult to carry out using your single local server or personal devices. So we are, in terms of computing the traffic, in terms of computing the load, in terms of handling the storage, for everything we are using the cloud. So this is how the cloud is being used for your prediction algorithm as well. So if you want to predict, okay, today is Friday night, Myntra site is going to be flooded with too many people. Maybe it's like a long weekend coming ahead, or maybe it's like a Diwali break, like 5-6 holidays that we have on Diwali. So it's like a long break. So expect Myntra to have, more traffic. So that kind of a machine learning algorithm, we cannot just use one server for that. Rather, we put our model, we put our training model onto the cloud, which is going to do all the job for us. This is how cloud and machine learning algorithms are kind of integrated, especially in the e-commerce websites. We definitely have more examples. Just shoot the examples if you can onto my chat so that, tomorrow or anytime further, I'm presenting the same thing to somebody else, I'm able to put in more insights on it. Let me check the site, the chats. Because when we are giving this presentation, I usually skip the chats. This is something my students always complain. Sometimes they don't talk, they type into the chat. So whenever I'm moving to the next slide, I just try my best to look into the chat box as well. Oh my God, the number of participants are rising. Now it is 180. So that's really a good number. So like within half an hour, I got a century rise in the number of participants. Awesome. Okay, let's move further. You know what, I'm missing those in-person conferences where you used to have samosas or tea or something, after 1.5 hours, you used to go on a nice place. There was nice samosas that were laid down. At the moment, I'm just having a glass of water with me. So that's sad. So whoever is the organizer, please send some teas, coffee, samosas to us so that, we can chat, we can enjoy, and we can also give the presentations. All right, so continuing with it, in the domain of machine learning, where you need a lot of computational power to train and build models, you need machines or servers with high computing power. So that is what we just talked about. So we need high computing power, when we have large amounts of data. So clouds make this possible. So this cloud thing is making it possible to have that high computational ability that is probably not going to be addressed, that is probably not going to be catered by your one simple sweet little alone server, right? So cloud is helping you with that. Cloud makes that possible. You can use them right from storing huge chunks of data, which we definitely know about, which can include logs generated from a website or data from the streaming site, to deploying your solution. So a cloud has a lot of applications apart from just being a storage device or maybe a storage model. So apart from that, it is helping you a lot when it comes to predicting or providing some kind of a solution or making some kind of an analysis depending on different data that we have over that entire cloud platform. Okay, so in recent times, the field of cloud computing has been witnessing a lot of advancements in order to build machine learning solutions at any scale. So yes, machine learning is at boom, and so is the cloud. So integrating both of these two things, it is bringing a new change in the IT industry for sure. So for instance, just an example, so Amazon SageMaker and Cloud Auto ML are some of the readily available machine learning services provided by AWS and GCP respectively, which enable building in high quality models specific to the business needs of the organization. So depending on the kind of business that you have, I'm again doing with the Myntra. I think whoever is, sponsoring this workshop or this STTP, send me the Myntra voucher. So whenever I come to India, I'll buy something for myself. Okay, so yes, so these Amazon SageMaker and Cloud Auto ML, these are some of the great machine learning services. And depending on the kind of business that you have, you can take these services and expand your business, predict the models, predict the sales, and do whatever. So this is what cloud computing and machine learning is all about. Machine learning and big data. So I see today in today's this brochure that was shared by Miss Divyani. Miss Divyani, just excuse me, if you're Dr. Divyani, then Dr. Divyani. If you're Miss Divyani, Miss Divyani. But yes, Dr. Miss, Mrs. whoever, Divyani shared with me the voucher, and there's somebody who is presenting big data and machine learning. So that's going to be great. So I'm just giving you a little overview on that. So big data represents large data sets that cannot be handled using a single machine. So we talked about cloud and machine learning. Now it's a little bit about big data and machine learning. So big data is something that is a huge data. That is why the word big data, and it cannot be handled using a single machine. So that is what big data is. All right. Okay, so moving ahead. So how is big data, just let me, distributed computing related to machine learning? So when I'm going to the previous slide. Yeah. So you have this big data, and then you have distributed computing. So your data is distributed into parts, and then you have a collaborated output. So, if you belong to some kind of electronics or electrical background, so we have a multiplexer and a demultiplexer kind of a thing, if you could just imagine that ways, right? So we have various inputs clubbed together into a single output. So you are distributing the data, multiplexing it, and then, just combining the data and giving that one single output. So this is something similar to that, and it is distributed computing. So how machine learning is collaborating or related to distributed computing? Machine learning is all about learning the underlying trends in the data. If the data is generated is very huge, that you need a scalable solution to process it without any latency or delays, then you need the concepts of big data. So machine learning, what is machine learning doing? It is trying to understand the different layers and making a kind of a conclusion. Big data is also doing a similar thing. It is handling the different data and then, trying to give you one kind of a solution. So big data is in itself a kind of a science. It's in itself a kind of a technology. So combining the concepts of big data will help you to advance, or will help you to refine your machine learning understanding. Say, for example, the concepts of physics, right? So physics is a mother for all the electronics that we have. So knowing the concepts of physics is definitely going to help you become a better mechanical engineer, or a better electronics or an electrical engineer, or maybe an engineer as a whole. So everything is revolving around physics. So knowing physics is something that is going to help you definitely to understand the different forms of engineering that we have, be it civil, be it mechanical, be it automotive, be it electrical or electronics, and even computers as for that matter. So similarly, talking about the big data and machine learning is working on different layers, and so is the big data. It is handling different big data, trying to distribute the systems, and then trying to plug the systems. The concepts of big data definitely are essential, and they're going to help you understand and make your machine learning algorithms much better if you know the ideas and the technology or the science how the big data works. All right, so let's come to machine learning. Any questions so far? Just let me look into the chat box. Okay. Okay, yes, the Christmas and the New Year. That's good. Yes. So I'm getting Christmas, I'm getting New Year, I'm getting Diwali, I'm getting okay, demand resource sharing. That's really great. And I really like the fact that you are encouraging me for the good presentation. Okay, keep just sharing your comments in here, and I'm going to be glad to see them. It gives you encouragement at 1 o'clock at night. So yeah, it's 1:11 a.m. So it gives you that boost that yes, you still have some 20 minutes to go. Keep chatting, keep writing your comments in here. Right. So understanding machine learning. So this is very important, and I just wanted to be a little focused in here if you are new to it, and even if you are old to it. So just maintain your focus. Okay. So a computer program is set to learn from experience E. So this is what a computer program does. It's not something very different. The computers were human made, right? Oh, yesterday I was just listening to one of the girls, and now that was like a little feminist. So she said that why it is man-made, why it is not woman-made. So now I've stopped using the term man-made, I say human-made, right? So computers are human-made, not man-made. So why should boys have all the fun, right? So okay, so computers are human-made, and therefore the way humans learn from experience, computers also learn from experience. So a computer program is set to learn from experience E with respect to some class of tasks that is represented by T and performance measure P. If its performance at task in T as measured by P improves with experience. So I know it's a lot of ABCD, not really ABCD, there's a lot of ETP and TPE. So what it is trying to say that if I have some experience and then I have some kind of a task and then I have some kind of a performance to be made, right? So this is probably my first lecture of AI. And maybe I give you a test to write and you score maybe 5 on 10. Tomorrow you study more on AI. And then tomorrow you get 6 on 10, and then 7 on 10, and then probably 8 on 10, 9 on 10, and then you are 100% perfect with your concepts of AI, ML, deep learning, or whatever. So this is what machine learning is all about. We are trying to minimize the error as we are gaining more and more experience. So when I'm talking about more and more experience, I'm talking about the more and more data sets that I'm giving to my system. So more information, more data I'm giving to my system, I'm getting more experience, and the probability of error that I would have to go to the final output would definitely going to get reduced. So anybody from the electronics or electrical background here? Anybody? No one? All computers ID? Yes. Okay. Yes. So we have Mr. Mahavir. We have Hanu Sahib. Yeah, ECE. Yeah, ECE rocks. Yeah, because I was from electronics and communication background as well. So that's really great to know that, yes, it is a kind of a feedback system, right? So you have a feedback. So with every feedback, I have an error. So when I have an error, I'm giving that error back to my feedback system. I'm trying to minimize that error, something like convolution or some kind of a feedback that you are giving to your system. So even if it is like you and me, as humans or as teachers or as any professional, we do get feedbacks from our HODs, we get feedbacks from our students, and definitely when we get the feedback, we try to work on those feedbacks. So we always take feedbacks with good spirit, right? So feedbacks are not to put you down, feedbacks are not to demoralize or demotivate you, they are to improve you or improve us as for that matter. So here, when I was working, I recently changed from NPower Canada to another organization. I'm now working with FDM. So that's been just 3 weeks since I switched. But yes, it was an old resume that I gave to Devyani, and she happened to say that I was working with NPower. But yes, NPower was one of the organizations where I received one of those tremendous feedbacks. So those feedbacks really helped me to improve upon my lecturing skills, improve upon my presentation skills. So they said, hey, Sonia, you're not supposed to do this. You shouldn't be getting bogged down with the feedback. So you should be always taking the feedback with a good spirit. And next time when you present, or next time when you deliver a lecture, it's going to be definitely better than the lecture you gave in the previous class or to the previous class. So this is what the machine learning is also all about, with experience, with more data, with more data sets, with more inputs. You are trying to minimize the error at every output. So this is what is expected from a machine learning model, that more inputs it has, more data set it has, less is the probability of performing an error or reaching towards perfection when it comes to making a decision. So this is what understanding or basic definition of machine learning or expectation from machine learning is. Okay. Oh, did I jump one slide? No. Okay. So yeah, so I'm not going into much of the details of how machine learning should work, but yes. Right. So there are many steps involved in building an end-to-end machine learning model. Applying the algorithm is one of the crucial steps of the entire machine learning pipeline, although there are other essential steps as well, such as how to get the data, where to store that data, and how to get your solution to the end user. So definitely algorithm, what kind of an algorithm you're going to use for your machine learning model is very important. That's actually the heart of the system. If you're not using a right algorithm, no matter what you're doing, you're not going to land up to the right solution or the desired solution. But apart from that, it's not just the heart of the machine learning model that is important. The other things are also important, just like a human body, right? Heart is important, but definitely how we see things, how we reproduce things, how we present things, how we hear, how we perceive, those things are also very important. So this is a kind of a machine learning pipeline that we have. We have a data ingestion, which actually means getting the data and storing it. Then we have data preparation, which is converting the data for the model to consume, right? So it has to be in a form that is understandable by the computer. It has to be in the form that is understandable by your model. And model deployment using the right algorithm to build the model. So you have the data, the data might be in form of images, the data might be in form of data or the text or something. So you have to prepare the data, which is understandable by your data model or by your machine learning model or machine learning algorithm. Something similar, because I saw so many people belong from the electronics and communication background. Just take it like an optical fiber. So you have an electrical signal, you have an optical fiber, and there you also have an electrical signal. So the conversion of electrical signal to optical and then back to electrical. So there has to be a kind of the conversion of data or preparation of data, which is understandable by the optical line, which is understandable by the model or by the algorithm that you are using to process your or to predict your information. Then we have model serving, that is taking the built model to the end user. So of course, we did some kind of prediction here. We did some kind of an analysis here on the gray side, and then we take it to the end user. And then model monitoring. So this is very important. We do sometimes forget the importance of model monitoring or data monitoring. This is something which is like kind of a human temperament. Once the things are done, once the things are established, we just like, okay, ab to ye ho gaya, ab kya kare, ab hamara kaam khatam. So wo nahi hai, kaam nahi khatam hua. We have to monitor it. We have to go through it. We have to understand that if there's some kind of a problem occurring there, we need to stop in there. We need to raise an alarm. We need to rectify it so that quality is maintained. So that is what we say, that no matter how much you do for a product, like in the production industry and IT industry or whichever industry you're working in, as for that matter. So even if you have the final product, monitoring that product for the consistency, for the kind of quality it has to maintain for some given period of time, like this computer I have, this laptop I have, it is having 5 years of warranty. So there has to be some kind of a monitoring algorithm that says, okay, until 5 years, you will not face any problem with this laptop or with this computer. So that monitoring is also very important once your product is delivered to the end user. So definitely the kind of algorithm you are using is important. The kind of conversion you are using to feed in your data to the model that you have is important. Storing that information is important. And then, taking that information to the end user is important. And then, of course, the recording. Okay, so should I start? Okay, so recording stopped. I got a prompt and then recording in progress. All right. Okay, so this is it about the machine learning pipeline. Please just tell me, let me know the time, because somehow when I'm in the presentation mode, I'm not able to see the time. So just let me know when it is 1 hour. Right, so just talking a little more about the different steps in the data pipeline that we have, or the machine learning pipeline that we have. So we have data ingestion, that is, can be defined as the process of absorbing the data for immediate use or storage. So storing the data, absorbing the data for the immediate use, that is what is data ingestion is. Then we have data preparation, is a process of organizing or structuring an unprocessed data set so that it can be used for analysis. That is very important. We have a random data, right? So We have chocolates, we have tops, we have pans, we have jeans, we have cookies, and maybe we have some fruit juices, maybe we have some soda, and so many other things, right? So I have so much of random data available, but probably I'm just focusing on the food industry. So with this data, I have to take out the tops, as in this kind of a top. I have to take out the pair of jeans. I just need to focus on cookies, on maybe soda, or maybe the juices, or other food items that we have. So sorting the data, organizing the data is very important. So data preparation is very important before we feed it to our system, before we feed it into the model. Because if we are not feeding the right data, we are not going to have the right analysis. Moreover, feeding a wrong data to your algorithm, even if your algorithm is one of the greatest algorithm that you are using, one of the finest algorithms you are using, but if the data you are trying to put into your algorithm is not appropriate, the computation time will be long. The probability of error would increase in terms of the output that you are kind of expecting. So preparation of data is very important. Excuse me. So data preparation is the process of organizing or structuring an unprocessed data so that it can be used for analysis. The first and foremost step in data preparation includes exploring the data set. Of course, you need to explore the entire data set. As I said, giving you an example, you have different food items, and then you have just a couple of clothing items as well. But your focus right now is to analyze the kind of food market that we have. So explore the data and just try to remove all the things that are probably not required. So that is what is called as data cleaning. So that I have put this slide in blue because that is not really the part of the pipelining, but then yes, that is a part of, sub part of data preparation. So data cleaning involves handling missing values. Oh my God, I don't know. Yes, data cleaning involves handling missing values and outlier values in the data set. First, you check whether the missing values are at random places across the entire data set or are limited to a part of data set with specific properties. So it's not only the redundant data that you need to get rid of, there might be some missing data as well. Some information that is probably lying somewhere else, right? So those are called as outliners. Anyone who knows what outliners are? Or outlier, sorry, I'm saying outliner, I don't know why. So outlier values, anyone? Okay, anyone? Okay, yes, I can say Kirti Sanjay. She knows what, okay, not in normal distributed. Yes, exceptions, that's awesome. That don't find in range. Good, not important in data. Yes, that's not really right, not important. Extremely out of normal values, yes. Exceptions, yes, awesome. So yes, if referring to the chat, you know what? It is really a cheat thing to refer to the chat. Sometimes you forget some concepts, so you get those information in the chat. So that's like a hack for us as teachers. So yes, so not perfect, it is an exception. So that's really great. So okay, so when we are talking about the outlier values, those are the exceptions. So sometimes those exceptions could be something that could be accepted for. Okay, exception is that probably I'm talking about all types of chocolates, and then we have one say Pepsi. So that's not the chocolate brand, and I'm just going to kick it out. But then sometimes these values really make a difference. What really happened? Why Pepsi was included in that entire data set, which is just talking about chocolates? Where did this Pepsi come in from, or where did this Coke come in from? Okay, so I'm not promoting any brand. Sorry if I'm doing that. So I'm not promoting Pepsi. I'm not promoting Coke. I'm just taking an example of a normal soda. So, I'm talking about different varieties of chocolates, or different brands of chocolates, maybe Lin, maybe Cadbury's, maybe, Kit Kat or Nestle or any other chocolate products or chocolate organizations or companies that I have. And suddenly I have this Coke or maybe a Pepsi or any other soda. I'll take it as an outlier value. I'll probably not consider it. But sometimes these values, though they are exception, though they are something which is very different, though they might appear to us as something which is not important, but sometimes they do make a lot of difference in kind of analysis that we are making. So if you're going to study deep into the AI or the ML algorithms, you will understand the significance of these outlier values more. That is probably beyond today's discussion. But yes, if any one of you wants to look deep into it, do have this outlier values thing. And if anybody who's looking into the research, right, in terms of taking ML or AIS for the research work, so a lot of research scope is there in this outlier value thing. So a lot is happening on this, because until now we were just focusing on the values that mattered, and now we are focusing on the values that don't matter, and trying to build algorithms for these outlier values. Just a tip for those who want to go into the research further. Okay, so first to check whether the missing values are at random places across the entire data set or are limited to the part of the data set with specific properties. Once you have identified this, you may simply discard that particular part of the data set or choose any of the following methods to impute these values. So, mean, median, mode, random sample imputation, replacing with an arbitrary value, missing value indicators. So these are a lot of things that you can really explore at your own pace. But yes, this is important. This is very interesting. Somehow I find this part of machine learning more interesting than the algorithm part. This because this requires a lot of mathematics. This requires a lot of mathematics, a lot of statistics, a lot of your basic mathematics like probability or your mean square errors and stuff like that. Again, belong to electronics, and my field was image and signal processing. So this particular domain or fragment of machine learning attracts me more than the algorithm itself. All right. So now we come to the other part of the machine learning pipeline, which is called as model development. So model development is a process that involves developing and validating models to arrive at the best solution for the problem at hand. So there are, excuse me, a lot of speaking, so just an itchy throat. Okay, so there are different types of steps which are involved. One is data partitioning. You're partitioning the data. Data partitioning, I think, again, a lot of you must be familiar with partitioning of the data. So this involves the creation of multiple subsets of data, namely training data set, test data, and validation data. Anyone, why data partitioning is important, or what do you understand by data partitioning? Yes, Kirti. Yes, high variance values. That's correct. Okay, Anita says data partitioning for testing our model. Absolutely correct, Anita. Okay. Anyone else? Data partitioning. Yes, for train ML. That's correct, Mr. Mahavir. To handle data set properly, data partitioning needed to separate important values from other data. Yes, Prof. Apurva Shah. Yes, Professor, you're absolutely correct. Okay, so just excuse me if I just call you by first name like Anita, Jyoti, or anyone. It's not to intimidate you or to disrespect you, but just that I don't know your salutation. I'm just calling you by your first name. So the way it is written in here, I'm just calling you with that. So no offense. I love you all. Okay, so we can't use same data for training and testing. Yes, we cannot. Yes, so awesome. So that's really a nice thing. Ms. Jyoti said that we cannot really use the same data for training and testing. So that is important. We are partitioning the data into the format that this part of the data is for the training, this part of the data is for testing, and this part of the data is for validation. Thank you very much. Okay, so that's really interactive. I like the way you are typing, and I'm really glad to see that so many of you are attentive to my presentation. So that's really an encouragement. All right, thank you. Thank you very much. So partitioning ensures that the model performs well on the unseen data, as it is possible that the model predicts extremely well on the training data, but not on the test data. This is something that usually happens with us as teachers, as professors, lecturers, trainers, instructors, that we teach well. There are students who are sitting in the class, nodding their head, yes, ma'am, yes, sir, we got what you're saying. And when it comes to writing the test, their attendance is 100%, and they're submitting the assignments on time. Even their class tests or internals that we conduct them, they're also going up to the mark. But when it comes to the finals, they are doing something which is not really that you predicted. So it is not really necessary that training data will give you the same result as a test data, or test data will give you the same result as a training data. So that is what is important. That is why it is important to have the partitioning of the data. Again, there are students who are probably never present in the class, who are never submitting the assignments on time, who are never in the laboratory, but still they get good marks, or they come out with flying colors when it comes to the final of the university exams. So training data, the kind of test that you perform, the training data, or kind of algorithm that you put on the training data might or might not be same that you get as a result when it is performed on the test data. So that is why partitioning becomes important. Okay. Can I get your mail ID, ma'am? Yes, of course. Don't call me ma'am. You can call me Sonia. Okay. I'm not that क्या बोलूं मैं हिंदी में बोलती हूँ मैं इतनी बड़ी नहीं हुई मैम मत बोलो सोनिया बोलो वैसे it feels really good to hear this ma'am. It's been some 4-5 years since anybody addressed me as ma'am. While I was in India, all the students used to, the way we address each other, ma'am, sir. But here in Canada, it's not like that. So it's really beautiful to see that you people are addressing me as ma'am. So that's really good to see that respect back. Thank you. Definitely, I'll give you my email ID. No problems with that. Once we are done with the presentation, I shall share with you my email ID as well. Okay, so moving ahead. Right, so then the next step is model selection. So what kind of a model will be best suited for the kind of, the machine learning algorithm that we have. Then, of course, we have model evaluation that estimates the error in the selected model. That is how well the selected model performs on unseen data. Selecting the appropriate metric is important aspect of model selection. What kind of a metric that you are using for your model? What is a parameter, right? So if somebody calls me that, okay, Sonia, you are not a good student. So what is a metric? How you're saying that I'm not a good student? It's just that you are comparing me with people who got 75 and above. Maybe you should be comparing me with the people who got 60 and above. Maybe I'm a good student with respect to them. So the metrics should be very clear. What kind of a comparison you are making? What is your baseline? What is your fundamental? So that is very important when you're talking about model evaluation. So whenever you are, first of all, don't evaluate any humans, but still, if you need to evaluate anyone, you need to have your metrics clear. You cannot compare apples with oranges. You cannot say this apple is sweeter than this orange. Totally different fruits, different kind of nutrients, different kind of flavors. This is vitamin C, this is iron. So you cannot compare iron with vitamin C. So be careful what you're comparing with. So your metrics should be clear with the kind of model when you are making the model evaluation. Model ensemble learning which is when the multiple models are combined, helps in reducing the error in the model. So that is called as ensemble, right? So you must have those of you who are fond of jewelry. I'm pretty fond of jewelry, right? So it's like a nice ensemble. So this is probably an ensemble of some like one solitaire and some kind of a white gold and then a little silver. So it's like a nice ensemble of different stones and different kind of metal and combined together to give this a beautiful ring. So ensemble is a collaboration of different things which will give you a combined good result. It's like साथ ही हाथ बढ़ाना, एक अकेला थक जाएगा, मिलके बोझ उठाना, right? So जब हम मिलके बोझ उठाएंगे, so things, the output would definitely be something that is going to be great. So ensemble learning, it is when multiple models are combined, reducing the error of the model. So probably my expertise is artificial intelligence as of now. Probably somebody else's expertise is image or signal processing. There's somebody who's very good at cloud computing. There is somebody who's probably good at marketing the things, right? And we are trying to analyze the images, or we are going to, trying to predict something about the images. So the person who is good with image processing is going to give me the data on that. I'm going to use my prediction algorithm. And then somebody who is good at cloud is going to put that data into the cloud. And then, the output or the kind of results that we have is going to be marketed by somebody who is specializing in marketing. So, together with different kind of specialities, different kind of expertise, the ensemble of it, the collaboration of it is going to give you a reduced error output. So one model would work well on a particular aspect of the data, whereas another may not work on other aspect of the data. Just like that, some particular model is working on some kind of a data. The other part of it is working on other kind of a data. So, combining all those different models for different fragments of data will definitely give you a better solution to your problem. Okay, so a model serving, so that's like probably the second last step. The model built in the previous step now needs to be served or taken to the end user. Model serving involves the following steps: that exposing the built models as APIs, or the application programming interface. So once this application of the machine learning model is built, the next step involves moving the code from the local, I'm sorry, that's annoying. Okay, from the local development environment to the staging or the production environment. A key aspect here is that you need to create an environment similar to the development environment. And this can be achieved using a technique called as containerization. So you are containerizing, you are putting it in one kind of a container, or putting it in kind of a box and then taking it further. So that is what containerization is. Okay, so the last step is performance testing, where you simulate similar real-time scenarios. So that is the last step, performing the testing. For example, a website with regular traffic of 100 users per minute may suddenly witness a surge of 1,000 users per minute during some kind of a sale or some kind of a festival, Christmas, Diwali, Eid, whatever. Performance testing involves simulating such unexpected loads and checking metrics such as response times and concurrency. Then, of course, we talked about model monitoring. We have the product, we have delivered the product to our users. Monitoring that model is very important. So monitoring means how the model is doing. So data logging, reporting, alerting, and resolution. So we are keeping a log of the data. We are keeping the log how your model is, performing on something. Then if some kind of something goes wrong, then definitely there has to be a reporting that should take place. After reporting, then alert should be sent to a particular user or an engineer who's taking care of that entire project. Hey, you delivered this product to someone, and there's some kind of things are going wrong in there. So there's a reporting that is happening, and then alert is sent to the engineer. The engineer is going to look into the problem, and then of course the last step is to provide the solution or the resolution. So model monitoring plays an essential part in making sure that model's performance does not deteriorate over time. So that is very important. Delivering the product is not just what you want to do. You want to make sure that it does not deteriorate over the time. Thank you. So that is it about my presentation. Okay, right. So that's it. And I think I have been speaking since almost 1 hour and 20 minutes or 10 minutes or so. So any questions? Yes, I will share my LinkedIn profile. I will not mind at all, Sheetal. I will definitely share my LinkedIn profile, nothing to hide. Yes, thank you so much. Okay, so my email ID is in here. sonia.jain.engr@gmail.com, and you can search me with the same ID on my LinkedIn as well. I don't have my LinkedIn URL in here. Just let me check if I can open my LinkedIn. Actually, I'm using my office's computer right now. So, but yes, you can definitely connect. You can find me with this on LinkedIn. This is the email ID that I use for my LinkedIn. So if you want to connect with me onto my LinkedIn, you can definitely find me in here. So I'm currently working at FDM. So these are the keywords that probably will help you to find me on LinkedIn. Earlier, I was working with NPower. Prior to that, I was working with Maritime Business College. And yeah, so these are the keywords, and definitely my name is Sonia Jain. Okay, there you go. So yeah, I want to hear some more voices. There's like a lot of robotic things which are happening in here. I can see chats, I can see, yeah, but I want to hear voices. It's been really long since I've heard human voices from India. Apart from mama and my family calling in me from there, I want to hear voices.
May I?
Oh, of course. Go ahead, Kirti. Yes.
Thank you, Sonia ma'am. That was an excellent presentation.
Thank you, Ms. Kirti.
The way you held the audience's attention was captivating. Actually, we as teachers should really can really learn from you as to how to make the lecture more interesting for the students. And I
yeah, and especially Miss Kirti. Should I address you as a Miss Kirti, or this is okay?
I'm Mrs. Kirti.
No. Why? No. You just call yourself
right.
Miss Kirti.
My
Why
first
should
name is more than enough.
No, Kirti, I just tell you, why should we women just tell our marital status saying Mrs. and Miss? These men are always Mr. So be Miss Kirti only. Don't tell your marital status.
Kirti is more than enough for me.
Okay. Yeah, Kirti, I think, because especially with this virtual environment in these past 2 years, 2 years almost now, more than 2 years rather, I've realized that, keeping the presentations and keeping these sessions more interactive is important, because half of the time students are online, but they are not present, right? And in the class, the scenario is really different. You can look into it, you can look into their expressions, see whether the student is attentive or not. But in the virtual environment, keeping the session very interactive is very important.
Yeah, yes, I have a very small question regarding, you were saying that outliers can be a very good topic for research. So can you suggest some topics, ma'am? Like
okay, I'll definitely, Kirti, can you just email me you just email me something, hi Sonia, and I will send you the topics that I have in mind, because yes,
I also find outliers very interesting, so I would really like to pursue, I mean, not my doctorate or anything, but I would like to do some kind of study regarding.
Yeah, definitely. You look into it, and you will find very interesting things about outliers. So if just email me, hi Sonia, we talk about outliers, and whatever information I have, I will share it with you.
Kirti. Thank you so much, Sonia.
No problem. Bye-bye. No problem. Anything else? Anybody? So should I wrap up?
Hello, Bonde ma'am.
Oh, ma'am. Okay. Participant, there is any questions?
May I, Sonia ma'am?
Yes, of course. Go ahead. I'm all in here.
Sonia ma'am, can you please elaborate more on validation data? Because many a times actually when we categorize it at broader aspect, we always say train, test, split. The most of the time we go for either it is 20-80 or maybe 75-25, 70-30. Hardly we actually put the validation word over there using the validation thing. So can you please just help me out for this particular concept, validation data, like how we can explain it in a more simpler way to our students?
Okay, yeah. So that's a very good question that you have put it. Like, what do you mean by validation, right? So okay, let me give you a very good example of this. What is your favorite dish, Jayshree?
Puran Poli, being a Maharashtrian.
Okay, so Puran Poli. So Puran Poli is Jayshree's favorite dish. So let's talk about Puran Poli. And you're making me hungry at 1:45 a.m. at night. And we don't get Puran Poli here in Canada. I mean, there might be somebody who's making at home, but not really the one that we have it in Maharashtra. Okay, so you are making a kind of a Puran Poli. Like, everybody has a different style of making Puran Poli. Somebody is making with wheat flour. Somebody is making different kind of flours, besan, wheat, or dal or bajra, and then making Puran Poli. Now, how are we validating that this is the Puran Poli that is actually Maharashtrian? How are you going to claim the fact that Puran Poli, which is coming from Jayshree's kitchen, is really the Puran Poli which is authentically Maharashtrian? So that is where validation comes into being. So when you're talking about validation, you need to have the data set. So maybe you're talking to 10 old women in your community, and all these 10 women come to you and taste the puran poli. Now, because they are old women, they have seen more tradition than probably you and me have seen. So they are going to validate, okay, this puran poli is 60% close. The other one would say it's 70% close to the original authentic puran poli. Somebody is going to say 55. And then when we have these 65, 75, 55% from those 10 experienced women, so make sure who is validating. The metric is important. It's not me or it's not your children who are validating, because they've never had the original puran poli. So the metrics that you are taking to validate the authenticity of your puran poli is important. So here the metrics that we have taken are the 10 old traditional women who probably are somehow involved in the culinary of Maharashtra. They are tasting your puran poli, and then they are giving the weighted values to the flavor or to the real taste of how puran poli should be. Now, collecting these 10 values from 10 smart, maybe they are great chefs, or maybe they are 10 women who are from authentic Maharashtra. Now, collaborating these values and then giving the output that, okay, Jayshree's puran poli is 62.56% close to the authentic Maharashtrian taste. Are you able to understand the analogy, Jayashree?
Yeah. I'm getting it. So as you mentioned, the metrics, what we are referring to, because many a times nowadays the performance metrics which is available is mostly we go for CF, the confusion metrics, which is also called as the error metrics for checking the performance and the actual genuineness of the machine learning model which is being done. Hats off to the example, really a very nice one.
Yeah. So that is what is important, that whatever metrics you are taking for any of these 3 steps or any other steps, as for that matter, that metrics becomes very important, very integral. So make sure that no matter what step you are into, the metrics that you are taking is emphasized well. So just make sure with that.
Okay, thank you so much. Have a great day, Sonia.
Thank you, Jayashree. Thank you, Jayashree.
Yeah. Thank you, everyone.
Okay, so thank you, Sonia, for your wonderful presentation on the ML and AI applications. You cover very nicely the basic concept of ML. And simultaneously, you can cover up the bank detecting fraudulent transactions, machine learning, and cloud. It's very useful for our participant, definitely. Thank you so much.
Thank you. Thank you so much. Thank you so much, everyone. I'm seeing a lot of questions in here. So I've shared with you my email ID. So whatever questions you have, just drop me an email, and I'm going to try my best to address with best of my ability. Thank you very much.
Dear participants.
Bye-bye.
Yeah. Bye, Sonia.
Bye-bye. Thank you.
Yeah, dear participants, one announcement for you. The next session will be start little bit late, 15 minutes late. Okay, so it is going to start almost 12:45. And now the attendance form and feedback form is shared with you. Please fill the attendance and join the session, next session at 12:45.